Well, I've torn into the rear of the tender and disassembled everything. The motor control board and all the pickups and everything appear to be excellent shape. I've taken the rest of the components off, and as I did, I was inspecting and I'm making notes. Here's a change, here's a change, 3, 4, 5, 6, 7, making notes on things that didn't work during the attempt. One is there was an interference with the board. Here was an interference when I tried to plug in the USB port to do a test. And here, a divider to separate the boards was a little too thick and it fit too tight. Here I'm making connectors rather than individual. I'm going to use, okay, thank you. I'm going to make a pair of 4-pin connectors right here. So you just unplug this, just snaps right off, right? Trust me, it does one-handed. I can't do it. It comes off. And then you have the 4 wires that go to it would plug into that, and I have a sample here, but this is just a 2-pin connector. We'll have 4-pin, 2 4-pin connectors, and those wires then would be routed where they need to go. I did make this one on the fly, but it seems to work well. I can plug it in, feed the speaker in. This may not be the speaker that makes it. It's pretty big. The other challenge then is this is the power in. You really don't need big wires sticking out when you're going to run power in. They can pick up noise and collect things. So I have here a female socket. I could shorten those lines and solder them right to those pins, and then just super glue or glue it right down to that board so that I just have my power cable from the source and just plug it in right there. What I've done just now, and I do have to get these off to show you what I did. There we go. These are the pins that we use to activate some of the sounds and the functions. And I've plugged this into a USB, which is sort of like into a computer. And that gives it a nice clean power signal so we can do testing. The thing that worried me was, did I do any damage to this particular system? This is the Puff and Chuff sound and control assembly. This is the Wemos, don't use metal. This is the chip, the brains right there. That's a mini microcontroller, mini computer. That's a Wi-Fi antenna. These are the inputs and outputs, and that's the amplifier for the speaker. So this is now live, and the program inside it is live. And what I wanted to be able to do was to test and see if all the functions, when it starts up, there's a expression of steam coming out of the engine. Steam coming out of the engine works. Now this should be the steam whistle. Very nice steam whistle. This should be the bell. And if I hold it, it should ring more than once. There you go. This is the chuff. So at every time that trigger gets pulled, the chuff goes out. Out here is a pulse of 3 volts to the fan for the smoke. Can't really test that, but you just assume for now, if we're chuffing, we're getting the 3 volts. I'll test it as I get further along. So now the next thing I tested was the battery and the charger, and I found that the charger, when I was powering the board without this USB, this has a USB also. So I put the USB as the input, and this power supply it's actually a charger. Okay, it's charger for this, but it's also the pass-through for the energy into this guy. And it's sort of a regulator and a charger. But I noticed when I plugged it into the USB port as if it was in a computer, it would get warm. And I also noticed when I played the sounds, I would get a lot of background hacking and carrying on as if something wasn't happy here. So I'm going to look at replacing this board. I have another one. I'm just going to take these solder links off, bring in the new board, and I've started to work on where it fits and how I want it to to be connected, and making sure that it's put together properly and that the test then is validated. So what I'm going to be doing is building from here out and testing as I go, making sure everything functions. Then the wiring process, I'll be taking this frame, finding out where these parts are supposed to fit and what is the distance and what is the routing, and making sure that everything is routed and has space and the wire is not too long and not too short. And everywhere I can, I have the opportunity to just use a socket and plug something together like you would expect on a real system. There's how you would plug in the two, and you're all set. That leaves you a much neater and a more serviceable assembly, and you won't have things touching, shorting, flying around. Plus, it takes care of the mistakes when you do red to red and you make a mistake because you're hot wiring things. I mean, I was soldering non-marked wire to different poles, and I got confused, and I took a plus to minus and a minus to plus. And as soon as I turned the power on, the board went pop. And that's a sign you had it polarized incorrectly. So that's the way it goes. So anyway, I'm going to back up, go through some of this stuff. I thought I'd show you some of the details that are involved in making sure you get this thing assembled properly. Once I get this done and I have a harness that I know I can make, I'll make the harnesses and include them if anybody wants one of these. I'll make sure that it's a safe, simple DIY, not hit and miss, not what I just went through. It'll be much improved. That's part of why you go through these things. So every step you try to make things better for the next guy or whatever your goal is. I really don't want to build these and install them on everyone's engine. I can't, even if you wanted me to. But what I can do is make the kits available, make the instructions available, get them to you at a very reasonable price with everything you need to do it yourself. That's what I'm hoping to do, is offer these out as a DIY kit for you. That's where I'm at. Okay, so I just had to call. Lunch is about ready, so I'm going to head up and take care of business. Later.